Hey guys, in my previous videos we did find the derivatives of exponential functions, something like e raised to the power. That power could be anything, any algebraic expression in terms of x. It could be 2x, x squared plus 1, or any other expressions. And if you need this extra help with these kind of examples and derivatives, the links to these videos would be down below in the description box, and feel free to go ahead and check it out. All of these problems require the chain rule. And what is the chain rule? Long story short, you need the chain rule when you are given a composite function. Meaning it's not just e to the x, it's e to the 3x. So your function, your exponential function e, is made of another function, let's say 3x or x squared or any power that looks more complicated than just x. Most of the problems you might be working on require to use the chain rule, since likely you are given a composite function and you need to know how to use the chain rule and when to use. And by the way, I do have a bunch of separate videos on the chain rule. All of these links would be down below in the description box, and if you need this extra help with the basic gist, the basic idea of the chain rule, go ahead, feel free and check them out. What if you are given something not just e to the x, you are given something like x times e to the x, or let's say 2x squared times e to the 3x, and you need to differentiate, you need to find the derivative of these kind of functions. What do? In a nutshell, you are given two things being multiplied together. You are given two functions, say algebraic and exponential. You might be given something like overall form, one algebraic function over exponential function, or vice versa, exponential function raised to this complicated power over algebraic function, something like x squared, square root of x, or it could be any radical of x. How to find the derivatives of these kind of functions? Don't worry, I'm going to break it down and I'm going to take you through all of these kinds. Alright, say you are working on something like x e to the x, and you need to differentiate this function with respect to x. First of all, as I mentioned before, you are given two things, two functions being multiplied together. And all you need to apply first is the product rule for derivatives. Yes, there is a product rule for derivatives. And all it says, if you have u times v, two functions, two algebraic expressions being multiplied together, so the derivative of this product is u prime v. So you need to take the derivative of the first term of the first function times the second function v as it is, plus the first function u as is without any changes times the derivative of the second factor v prime. So this is the product rule. And by the way, I do have a separate video on the product rule. Also, the link would be down below in the description box. And if you need these extra examples on how to use the product rule for algebraic functions, go ahead and check it out. Now, let's put it to the test. Your first function, it's gonna be just x. This is u. And what's left over, namely e to the x, that's gonna be your second factor, second function v. And you need to take the derivative of this product. So all it says, you need to take the derivative of the first factor, which is x, and the derivative of x, it's gonna be just 1, times the second function, e to the x as this. So e to the x, plus we need to add. Now basically the derivatives kind of shifted, if it makes sense. So it becomes the first function as is, namely x, times the derivative of the second function. And remember that the derivative of e to the u is going to be e to the u. So it's the exponential function, the derivative remains the same. So you're going to write just e to the x. And since it's just e to the x, no chain rule, nothing crazy, nothing fancy, and basically we are done. This is your derivative. So normally we are going to ignore this one, neglect it, and I'm going to rewrite my final derivative. So it's going to be e to the x plus x times e to the x. Well, you could just simply write e to the x plus x e to the x, or you could factor out e to the x, since both of these terms, they contain this e to the x common factor. If you will, if you have to, or if you want to, you could simply pull it out. What's left over is going to be just 1 plus x. Again, it's kind of extra, and it looks like more proper and neat form. So that's your derivative. Okay, say you have to find the derivative of this one, 2x squared e to the 3x. The same steps as before, just spot your u and v. So your first factor, it's gonna be 2x squared, so this is your u. And what's left over, namely e to the 3x, that's gonna be your v. Stick to this pattern and you are good to go. So the derivative equals u prime, the derivative of 2x squared, your first term, your first factor. So since you are given this constant 2, you want to keep it first of all, and the derivative of x squared, remember the power rule. So by the power rule, it's going to be just 2x. So this 2 gets multiplied by 2x. Times the second function as is. So e to the 3x, I'm going to rewrite as is. So e to the 3x power. Plus, we're going to add. Now switch over the first function as is, 2x squared, times gets multiplied by the derivative of the second function. So look at the second function. So now we are going to focus on e to the 3x. So remember that the derivative of e to the 3x, it remains the same. It's going to be e to the 3x. And we are not done yet, since you are given a composite function. Your exponential function e is made of another function, this exponent 3x. You have to apply the chain rule at this point. It's very easy to forget, I know. Pay special attention and watch out these composite functions that can be kind of hidden in your original function. So by the chain rule, we have to take care of the derivative of the exponent 3x. So the derivative of 3x is going to be just 3, since the derivative of x is just 1. X goes away. So this term gets multiplied by 3. And technically we are done with the derivative, but we don't want to leave the house like this. It looks bulky, off kilter, and it's considered nice, proper way of writing your expression in the simplest form possible by combining like terms, pulling out the common factors. So let's do it. First of all, you want to combine these 2 and 2, so you're gonna left with 4x e to the 3x from the first term. Moving to the second one, 2 times 3, you are left with 6 x squared e to the 3x. And we're technically done again, but look at these two terms. So 2x appears in both terms. Also e to the 3x power. Both of these terms have this greatest common factor, namely 2x times e to the 3x, that can be taken out, pulled out in front of your expression. So that would leave us with, again, 2x, since you are given the true even coefficients, so both of them divisible by 2. And also e to the 3x, they're going out. So what's left over? You have 2 from the first term, and you have just plus 3x from the second term. And we're all done. That's your derivative. Alright, the last thing I want to leave you with, 2 square root of x e to the x. So you need to differentiate this function with respect to x. Again, your first term is going to be 2 square root of x, and your second v is going to be e to the x. Again, stick to this pattern, stick to this product rule, and you're all set. First of all, we need to take care of the derivative of 2 square root of x. Since you are given the constant 2 in front, you want to keep it. So rewrite 2 as this, times the derivative of square x is going to be 1 over 2 square root of x. And this is kind of a special rule which basically comes from the standard power rule. So if you do remember this one, go ahead and write the answer. If you don't remember, so rewrite your square root of x as a x to a half power. Apply a power rule at this point, and basically you end up with something like this. So anyway, the derivative of square root of x is going to be 1 over 2 root of x. So we're done with the derivative of the first term of the first function, but obviously we're not done with the full derivative. So this one gets multiplied by the second function v as is, so e to the x. Moving on, plus you want to add. Now the first function, namely 2 square root of x as is, as it is, gets multiplied by the derivative of e to the x, and again recall that the derivative of e to the x is going to be the same. Go ahead and just write e to the x in place of this v prime in your product rule. And again, technically we are done, but it needs simplifying. So first of all, this 2 would cancel this 2 goes away. Write it, so I'm going to place e to the x on top of the first fraction. And you have still square root of x on bottom, plus. There is nothing to do with the second term. I'm going to rewrite it as this. And final step, I would get the common denominator in order to combine these 2 terms and rewrite them as a one single term, as a one single expression. So the common denominator is going to be square root of x, the least common multiple or the least common denominator. E to the x goes on top, plus, and basically what you want to do, you want to multiply the second term by square root of x, since we want to get the square root of x in the denominator. So 2 square root of x times square root of x, you would be left with just 2x e to the x, since square root of x times square root of x. So they would leave you with just x. And basically we are done. Look at your top, you have 2 terms being added and you have e to the x term. It appears in both terms. We could simply pull it out. So e to the x, this is the final step. Square root of x remains the same. So parentheses and then what goes inside. So instead of the first term, you are left with just 1. Plus from the second term, you end up getting just 2x. Now, squeaky clean. Looks pleasing to the eye, if you will. So, and we're all done. That's your derivative. Alright, I hope it has been helpful to you. Huge thanks for watching and train your brain. I know everyone hates math, but if you like my video, please hit this like, share with your friends, leave the comments down below. Be sure to smash that subscribe button and turn on the notification bell so you'll not miss out my new uploads.